Welcome to Through Projects. In this video, we are going to explain about a project titled DisCOV Distributed COVID-19 Detection on X-ray Images with Edge Cloud Collaboration. So now coming to the introduction part, DisCOV demonstrates a commitment to democratizing healthcare access. Its distributed architecture allows healthcare facilities in remote and underserved areas to benefit from the state-of-the-art COVID-19 detection capabilities. This not only aids in early detection but also helps alleviate the strain on healthcare systems during pandemics. In summary, DisCOV is a cutting-edge solution that showcases the potential of technology to enhance healthcare outcomes, particularly in the times of crisis. This innovative system harnesses the power of edge computing and cloud collaboration to enhance the detection of COVID-19 in X-ray images, thereby facilitating early diagnosis and timely treatment. So now coming to the objective part for this project, the DisCOV encompasses improving accuracy, speeding up diagnosis, and enhancing accessibility, all of which are essential in the global effort to combat the COVID-19 pandemic effectively. This system represents a critical advancement in healthcare technology with the potential to make a significant impact on public health outcomes. One key objective of DisCOV is to enhance the accuracy of COVID-19 detection through advanced image analysis. So now coming to the requirements part, here we have two types of requirements, hardware requirements and a second one is software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 8 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of work, here first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate, machine learning and matplotlib and C1 for visualization are important. Second, here we have data exploration COVID-19 data. In this we have image and its extracted feature values, analyzing the dataset containing COVID-19 data including X-ray images and related feature values. Then next we have image and data processing. In this we have first checking and dropping the null values, reviewing the data for missing data and removing any instances with incomplete information. Second one, here we include filling the null values in the image and data processing for reviewing the data set for missing the data, addressing missing data by replacing or imputing values which are needed to maintain the data integrity. Next, here fourth we have image visualization with normal histogram. In this we include using image pillow, employing the Python imaging library, that is pillow, to visualize images and create histograms to understand the distribution of pixel values in these images. Next, here we have fifth, image processing. In this we have using image data generator, employing image data generator, a tool in deep learning for data augmentation and pre-processing. First one, here we have rescaling the image, adjusting image scale to a specific range for consistent processing. Then next we have shear transformation. In shear transformation, applying the shear transformation to the images to improve the model robustness in this. Next we have zooming the image. For zooming the image, introducing zooming variations to augment the data set. Then next we have horizontal flip, flipping the images horizontally for adding the diversity in data. And the last one, here we have reshaping the image, adjusting the image size or shape to match model input requirements. Sixth, here we have feature extraction the data into training and the validation set. Separating the data set into training and validation sets, a standard practice in machine learning to evaluate model performance accurately. Seventh, here we have building the model. In this we include DisCOV-Net, developing a custom neural network architecture called DisCOV-Net for COVID-19 image classification. The next we have Inception V3 benchmark model. So utilizing the Inception V3 in the benchmark model architecture as a benchmark for the comparison. Next we have MobileNet V2 based LDT algorithm. So creating a model based on the MobileNet V2 for the specific algorithm which likely used for the feature extraction. Then next we have SqueezeNet based AlexNet. So developing a model based on the SqueezeNet inspired by the AlexNet architecture in the SqueezeNet based AlexNet model. 8th, here we have training the model and dumping the model, training the selected models on the dataset to learn patterns and make predictions. 9th, here we have Flask framework, local host sign up and sign in with SQLite 3. So here in this, we have to implement a web application using the class framework to provide the user functionalities for the sign up and sign in the SQLite suite. Then here we have user uploads the image for analysis, allowing the users to upload the images to the web application for the COVID-19 analysis using the trained models for uploading the images for the analysis. 11th, here we have the given images processed using Keras image to array, converting the user provided image into a numerical array format suitable for input to deep learning models. Next, here we have reshaping the image, adjusting the image dimensions or shape to match the requirements of the model's input layer. On 12th, here we have trained model. Our model is used for predicting user data and employing the previously trained deep learning predictions to make the predictions on the user's uploaded data, in this case likely COVID-19 detection in the image. Next, here we have predict with model for outcome, using the trained model to perform predictions based on the processed user data, such as classifying the uploaded image as COVID-19 positive or negative. And the last one, here we have displaying the final outcome, presenting the prediction outcome to the user, typically in a user-friendly format within the web application interface. This may include indicating whether the image shows signs of COVID-19 or not. So now coming to the execution part. To execute the project, first we need. So now here you can see that we have a folder which is named as data. In this folder, it contains the dataset which is used in this project, and the folder named as static. This folder consists of files related to TSL, JavaScript and Bootstrap files, and the folder named as templates. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Next, here we have app.py file, which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML template. Next, here we have this file, which is a Python notebook file, which contains a combination of code, graphs, and outputs all in one place. It allows the user to write and execute code in individual cells, making it a popular choice for data science. Next, here we have signup.db file. This file appears to be the database file which is used to store the information. So now just copy the path from here, open the Anaconda prompt, type the cd command followed by a space, and now the space the path over here and hit the enter button. Now type python app.py and now just hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. So here you can see that the link has been posted over here. Just copy this link and paste it into any of the browser. So here I am using Chrome. So just paste this link over here and now hit the enter button. So here you can see that this is our home page. Now click on the sign up button over here. Just enter the username, full name, email, number and password over here for doing the registration. Here I have already done the registration, so now simply click on sign in button. Now just enter the username and the password over here which you have created while doing the registration, and now click on login button. So here you can see that it is showing upload your image to be classified. So click on choose file button, and I'm choosing this image and click on open button, and now click on upload button. Here you can see that the prediction for the result uploaded is showing this over here. It is showing that for the given input image the cancer type is normal. Let's try with another example. So click on choose file. So here I am choosing this image and now click on open button, now click on upload button. So here you can see that the prediction for the result uploaded image is this. It is showing that the uploaded image for the cancer type is normal. By uploading another image by clicking on the try again button, you can simply test with this. So now just click on graph button. Here you can see that there are many different graphs over here, which is representing different accuracy by using the different models. And now by clicking on the sign out button, you can simply log out with this. So now coming back to the conclusion part, as we look towards a future where healthcare systems must adapt to emerging threats, DisCOV sets a precedent for leveraging cutting-edge technology to address global health challenges. Its impact extends beyond the current pandemic as the lessons learned from its development and deployment can be applied to future healthcare crises. In essence, DisCOV represents a beacon of hope and progress, showcasing the potential for innovation to transform healthcare and protect the well-being of individuals and communities worldwide. The author mentioned to use deep learning models like DisCOV benchmark model-based Reception v3, LD3 algorithm-based MobileNet v2, and Squeeze net-based LXNet in which LDT got 94% of accuracy. We applied same model with COVID-19 data from that MobileNet v2 based LDT algorithm got 99.5% accuracy. So with MobileNet v2 we built the model and it is used for detecting the result for the user input. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.